Hello, grade 12 learners. Welcome to another exciting session of mathematical literacy. This lesson is proudly brought to you by the Free State Department of Education in collaboration with Pagama Research and Development. My name is Nikki Wezulu, and today we will be looking at the topic of measurements. At the end of this lesson, you should be able to calculate perimeter, area, volume, and perform conversion calculations. You should also be able to change the subject of a formula and correctly substitute values into a given formula. These are the terminologies that you must familiarize yourself with in measurement. You make sure you know how to explain these concepts because these will be examined. The examiner can ask you to define the weight capacity. They can ask you to differentiate between capacity and volume. They can ask you to explain perimeter according to the given context. So you make sure that you go and revise these terminologies so that if you come across any concept in the exam, you are able to answer that. When the first part of measurement, it is conversions. I always tell learners that if you can perform conversions, then you know mathematical literacy, then you will pass your paper 2. With the conversions, the first one, it is your length or rather your distance conversion. And this is the metric conversion. Let me write it down for you. This is the metric conversion. This and this at the bottom, these are your metric conversion. These are the conversions that we are using here in South Africa. And therefore, you are expected to know these conversions by heart. The examiner will not give you a conversion factor between kilometers and meters or centimeters and millimeters. It means you should be able to know how to convert from meters to centimeters. By now in grade 12, you must know that the conversion factor between a meter and a centimeter, it is 100. A conversion factor between a centimeter and a millimeter, it is 10. And we know that when you are this side, this is the bigger unit. So as you are moving that side, you are moving towards the smaller units. Therefore, if you are moving from a bigger unit to a smaller unit, you are always going to divide. If you move from a smaller unit to the direction of the bigger units, you are always going to multiply. And then we also have the weight or rather the mass conversions. That is the conversion between your tons, your kilograms, your grams, and your milligrams. This one is less complicated because the conversion factor between them is just 1,000. So again, a ton, it is the biggest unit. Milligram is your smallest unit. If you are moving from a bigger unit to a smaller unit, you are always going to divide. But if you are moving from a smaller one to a bigger unit, you are always going to multiply. You are expected to know this by heart. You must, the most common conversion that they will ask you, it is between grams and kilograms. And then there's also the conversion for capacity or rather for volume, capacity or volume. That is the conversion between your milliliters, your liters, your kiloliters. I'm sorry about this one. Your milliliters, your liters, and your kiloliters. So what you need to know is that the conversion between your liters and your milliliters, the conversion factor there, it's 1,000. And the conversion factor between your kiloliter and your liters, it is what? It is also 1,000. So a kiloliter is bigger than a liter, meaning if you are moving from this side going to that side, you are going to divide. Whereas if you are moving from this side going to that direction, you are going to multiply because you are moving from a smaller unit to a bigger unit. So that is the trick. Every time when you are moving from a smaller unit to a bigger one, you will always multiply. When you move from a bigger one to a smaller one, you are going to multiply. Yes, I think I showed you this trick the other time, that if you are moving from a smaller unit to a bigger unit, we are doing what? We are dividing. If we move from a bigger unit to a smaller unit, what are we going to do? We are going to multiply. And then you must also know your time conversions. Time is very important and is one of the sections that are very challenging in your paper too. So these, you are expected to know this by heart as a learner in grade 12, that 1 minute is equivalent to 60 seconds, 1 hour is equivalent to 60 minutes, 1 day gives you 24 hours, 1 week gives you 7 days, a month, it in Mestlit we work with a month that is equivalent to 4 weeks, but we know it can be more than that. And then a year is equivalent to 365 days. You must know that if it is a leap year would mean that this would mean that we've got 366 days if it is a leap year. And then that also means that it gives us 52 weeks. Oh, there is the leap year. I'm sorry, I didn't see it. A leap year would give us 366 days. A leap year means it is that 1 year whereby February ends on the 29th. So a leap year happens every 4 years. And then when you talk about a decade, we are talking about a period of 10 years. When you talk about a century, we are talking about a period of 100 years. Another thing that is also important, you must know which month has 30 days, which month has 31 days. I like to show learners this method of using your fingers like this. When you are using your fingers like this, the first finger, the first bone on the finger, that is your January. It means when there's a bone, it means that month has 31 days. And then in between is just a gap. That gap will indicate 30 days. So that is your February. March is on the bone. It means March has 31 days. April is in the gap, 30 days. May on the bone, 31. June in the gap, 30. July is on the bone, 31. August is also on the bone, 31. September is in the gap, 30. October on the bone, 31. November in the gap, 30. December on the bone, 31. So that is how you should know which month has 30 days, which month has 31 days. This information is very important when you are given, maybe you have to calculate the number of days between 2 or over a period of 3 months. So you must know which month has 30 days, which month will have 31 days. And then the conversion between your speed, distance, and time. You will never write a paper through and you don't perform calculations based on your speed, distance, or time. And the trick thing about this question is that the formula will always be provided to you, but it will not be the formula that you want to use at that particular time. The examiner can be asking you to calculate time, but instead of giving you the time formula, they can give you the speed equals to distance over time. Here, they expect you to manipulate the formula. They expect you to make time your subject of the formula. So what we do, we use this triangle. This triangle, we call it the DSTV. It is the DSTV triangle, and then you draw a line. Then what you need to know is that this line here, it means what? It means division. When you see this line, it means you must divide. And then this line here, this one here, the cross means multiply. Meaning if you are looking for speed, here is the speed, it is highlighted. You will write speed. What is on top of the speed? It is the D for what? For distance. What is at the bottom? It is T for what? For time. And what does this line mean? This line means we must divide. Hence, you see the division line. Meaning when you want speed, speed will be equals to distance over time. And then when it comes to time, here is your time here. If you want time, you will highlight time. What is on top of time? It is distance. There is the distance on top. What is at the bottom of D? It's S. There, it's your S. It is your speed. And then remember, what is the meaning of this line? It means you must divide. So there is the division. So time equals to distance over speed. But then if you wanted distance, the distance now is on top. So everything else, so the distance is here, it's on top. So everything else, you write it as it is. You will write distance equals to, you write the S. Where is the S? Is not on top, it's not at the bottom, it's right next to the T. So you write it next to the T. But in between, they are separated by this line. And this line, we said it means what? It means multiplication. Meaning if you want to calculate distance, you will say distance equals to speed multiplied by time. So make sure that you know this triangle by heart, because this is going to come in very handy in the exam when you have to calculate either speed, distance, or your time. And then there is the conversion of temperature. Remember, with temperature, we've got the temperature that we use. We've got the units that we use to measure temperature in South Africa, the imperial units, which is your degrees Celsius. In South Africa right now, we have been complaining about the heat, that it's so hot that the temperatures are reaching your maximum of 34, 35 degrees Celsius. So our unit of measurement there, it is degrees Celsius. But then that is the metric unit. We have what we call the imperial unit. The imperial unit are those units that are used in other countries like the United States. So with the imperial units, they don't use the degrees Celsius, but rather they use the degrees Fahrenheit. So you will be expected, of course, to perform calculations between degrees Celsius and degrees Fahrenheit. The examiner can either give you the temperature in degrees Celsius and ask you to convert it to degrees Fahrenheit, or they can give you the temperature in degrees Fahrenheit and ask you to convert it to degrees Celsius. But the beauty of this section is that you are not expected to know the formula by heart. The formula will always be given to you in the exam. Yours is just to substitute the values and you punch them as they are on the calculator until you get to the answer. This is actually one of the easiest questions. It is normally for 2 or 3 marks. If you are just going to calculate, it is 2 marks. If the examiner wants you to round off the answer, then that would make the question to be for 3 marks. But this is a very easy question. All of you are supposed to get this correct in the exam, because you just substitute the values and then you punch them as they are on your calculator. Where you see the bracket, you insert the brackets. Then you'll get 100% accurate answer. So that is the conversion on the temperature. Once you've mastered your conversions, you are confident about the conversions. Now it comes the sections of your perimeter and your areas. With the perimeter, you must understand and you must remember that when you talk about perimeter, we are talking about the distance around a 2D shape. So the distance that is surrounding a shape, that is what we call a perimeter, the total length of a shape. With perimeter, our focus is on the outside boundaries. We are not interested with what is happening inside. We just want the total of the outside boundaries. So these are the 4 basic shapes that we work with in mathematical literacy: your square, your circle, your rectangle, and your triangle. You need to understand that you guys are now in grade 12. Therefore, you will not be given a triangle like this in the exam and they say calculate the perimeter, or a square like this and they say calculate the perimeter. You will be given a complex shape, and from that complex shape you should be able to identify your circles, you should be able to identify your triangle, you should be able to identify your square, but it won't be given to you on a silver platter like that. So if you were to calculate the perimeter of a square, remember one of the properties of a square is that all the 4 sides are equal. So if this is a side, this is also a side, this is a side, this is also another side. So if you want the perimeter, you will say side plus side plus side plus side. You add all the 4 sides to give you what? To give you the perimeter. And then if you get a formula like this in the exam that says perimeter equals to 4 multiplied by side, you don't panic. 4 multiplied by side, it means you've got how many sides? 1, 2, 3, 4 sides. So you just add all those 4 sides. And then when it comes to a circle, the perimeter of a circle is called a circumference. Don't forget that in the exam. With a circle, we don't refer to the distance around a shape as a perimeter, but rather we refer to it as a circumference. So with the circumference, again, there is a formula. The formula will be given to you. You do not have to memorize it. The first formula is the circumference is equals to 2 pi r. So this is the same as 2 multiplied by pi multiplied by the radius. What is the value of pi? The value of pi will always be given to you in the exam. Always. You don't have to stress and ask yourself, what is pi? And you always work with the pi that is given to you. Don't use the pi on the calculator. Don't use the pi that you learned when you're doing mathematics. You use the pi that would have been provided to you in the exam. Or this formula, you use it when you've got the radius. If you've got the diameter, then you use this formula that says circumference is equals to pi multiplied by the diameter. So either one of these formulas will give you the same answer. Remember, with the circle, the one that is provided here is got a radius, but sometimes you'll have a circle that has a diameter. So what you need to know with the circle is that if you want a diameter, a radius is half of your diameter. A diameter is a full length, but with the radius would be from here up to there. This part would represent what your radius. Example, if your diameter is equals to 10 centimeters, that means that your radius would be 10 centimeters divided by 2. Therefore, your radius would be 5 centimeters. So that is the relationship between a diameter and a radius. And in the exam, you will not write a paper 2 again, and then there's no way where you have to either find a radius or find a diameter. So the examiner will give you a radius and ask you to find the diameter, or they will give you the diameter and ask you to find the radius. Either one of the two, one of those will be examined. So it must find you ready. You must know what to do if that is the case. And then the perimeter of a rectangle, you apply the same principle that you applied when you were calculating the perimeter of a square. The only difference is that with the rectangle, remember with the square, all the 4 sides are equal. But a rectangle, only the opposite sides will be equal. Opposite means those sides that are facing each other. So this is the length. This will also be the length. And then the width, this side will also be equal to this, meaning that this is also the what? The width of your rectangle. Therefore, if we calculate the rectangle here, the perimeter will be equals to 2 times length, because you've got 2 lengths, plus 2 times width, because you've got 2 widths. Or you can just say perimeter equals to width plus length plus width plus length. Now you are doing it manually, 1 by 1. That is how you can do it if you like. And then when it comes to a triangle, these letters A, B, C, they mean nothing. They just represent the sides. So you don't panic and wonder, what is A? What is B? No. This A could have just been side 1. This could have been side 1. This could have been side 2. This could have been side 3. So if you wanted the perimeter of this triangle, you will take this side plus this side plus that other side. Meaning that it means that perimeter is equals to side A plus side B plus side C, as it is shown here. Or you can just say perimeter is equals to side 1 plus side 2 plus side 3. This is how you can calculate the perimeter. The beauty of this section of calculating the perimeter area and all the others is that you don't have to memorize the formulas. The formulas will always be provided to you in the exam. So whenever you have to calculate, the examiner will also give you a formula. So you don't have to worry about that. Here is an example of a perimeter. And this is the perimeter. This is an irregular shape. We don't know what type of a shape is this. And we don't know whether it's a triangle, So whether it's a rectangle or it's a square, it doesn't have a shape. So this shape, we call it an irregular shape. So if we're to calculate the perimeter of this shape, of course, our focus would be on the distance outside a shape. We are focusing on this part that I'm highlighting red. That is the part that we are going to calculate. We don't care about the inside. Our interest is what is the outside. This is what we are working with. So before you can calculate your perimeter, number one, check if your units are the same. What are the units? Like 5.5 centimeters, this centimeter, this is your unit. So are the units the same? I'm looking at all of them. All of them are in centimeters. All of them are in centimeters. Apologies for that. That means that we are happy our units are the same. So let us see now if we've got all the sides. We've got this side, we've got this side, we've got this side, we've got the 6, we've got the 1, we've got the 3, but now we are missing this side. So for us to find this side, how do we find this side? We know that from here up to here it is 3.4. So if you take out this part, this is 2. If you take out this part, this is 1. Whatever is left would be 4 for this part. So let us do it together. We'll say 3.4 centimeters minus this 2 here, minus 2 centimeters, minus this 1 centimeters. The answer would be 0.4 centimeters, meaning this part here it is 0.4 centimeters. Now let us calculate the perimeter now. The perimeter would be 3.4 centimeters plus 5.5 centimeters plus 0.4 centimeters plus 3 centimeters plus 1 centimeter plus 6 centimeter plus 2 centimeter plus 2.5 centimeters. I hope I'm not leaving any value behind. I hope you guys are also doing this with me so that we can see if I made a mistake. Let us now do this on our calculators. We've got 3.4 plus, oh, it's not 55. My goodness, what a big mistake. You make sure that you don't make this mistake. It's 3.4 plus 5.5 plus 0.4 plus 3 plus 1 plus 6 plus 2 plus 2.5. The answer that I'm getting, I hope you guys are getting the same answer. I am getting 23.8 centimeters. Remember, with perimeter, it is measured in single units, not the square units. So the answer there, it is 23.8 centimeters if we were to calculate the perimeter of this irregular shape. And then the next item, it is your area. Remember now with area, again, the same thing that I'm going to emphasize as I did with perimeter is that you will always be provided with the formula. Number one, when you have to calculate the area. And then secondly, if you have to calculate, check and make sure that all your units are the same. The units must always be the same before you perform any calculations. You cannot perform calculations with units that are not the same. And then what you need to know again is that it's the same thing as perimeter. We will only show you the basic shapes. These are the basic shapes, but you will never in the exam be given a square like this and the examiner says calculate the area of that square. No, it doesn't work like that. So here the area, they say the area, it is side squared. Side squared actually means that area is equals to side multiplied by side. That is where the side squared is coming from. And the formula for area of a circle, its area equals to pi multiplied by radius squared. If you see just pi r, it means multiply by the radius squared. The common mistake that you guys make in the exam, when you substitute, you always forget to square the radius. Remember that you must always square the radius. And in this circle, they gave you the diameter. They said that diameter equals 250 meters. If you are in the exam, immediately you write it down that, oh, since radius is half of the diameter, it means my radius would be 25 meters. So let us do this quick example and calculate the area of the circle. The area would be, remember I said the value of pi, you will always use the value that is given to you. And in Meslit, we work with pi equals to 3.142. You don't have to know this. It will always be given in the exam. Multiply by, what is the radius? It is 25. But that 25 must be what it must be? It must be squared. So we say this is equals to 3.142 multiply. You take out your calculator. On your calculator, 25 squared means 25 multiplied by 25. Not 25 times 2, please, no. So this is 25 times 25, and I am getting 625. And then we multiply this by 3.142. The answer that I'm getting there, I hope you are getting the same answer. It is 1963.75. And then it was in meters because it's area. The answer would be meter squared. So this is how you calculate the area of a circle. A very popular question in the exam. I think for the past 4 years, every final exam paper, there's a question where you guys have to calculate the area of a circle. And then your brothers and sisters, they keep making the same mistake when they have to square. Number 1, remember, you check that your units are the same. Number 2, if you are given the diameter, you convert it to a radius. Number 3, you substitute. Number 4, you make sure that your radius is squared. That's it, then you've got it. And then the area for calculating the rectangle, it is length. For the formula for calculating the area of a rectangle, it is length multiplied by width. And then when it comes to a triangle, the formula for calculating the area of a triangle, it is half multiplied by base multiplied by your height. So that is the formula. And this represents your base and this represents your height. That is how you calculate the area of a triangle. And then if you were to calculate the area of this shape, this is an irregular shape. So you can't say that I'm gonna use let me use maybe a rectangle formula, or let me use a square formula. No, you can't choose, you can't decide. So the best thing that you can do for yourself is to cut this shape into manageable pieces. You can either cut it like this, and then you cut it like this. So this means that you actually have how many rectangles? You have rectangle 1, you have rectangle 2, you have rectangle 3. Then it will be easier for you to calculate. You can calculate the area for rectangle 1, calculate the area for rectangle 2, calculate the area for rectangle 3. Then you add all the 3 areas. Then it will give you the total area of this particular shape. And then we've got a surface area. The difference between a surface area and the area that we're doing in the previous slide is that area focuses on 2D shapes, whereas surface area focuses on a 3D shape. I hope you can see the difference. And with the 3D shape, we work with the rectangular prism, we work with a cube, we work with a cylinder. Again, you do not have to memorize these formulas. This is the formula for calculating the surface area of a rectangular prism. This is the formula for calculating the surface area of a cube. This is the formula for calculating the surface area of a cylinder. You don't have to memorize it. It will be provided to you in the exam. The same with volume. Volume focus on your 3D shapes. The volume of a rectangular prism is this one. The volume of a cube is this one. The volume of a cylinder is this one. You do not have to memorize them. They will be provided to you in the exam. Like this one, remember I said for pi, we use 3.142. But again, this will also be provided to you in the exam. Let us look at the possible exam questions that we can expect under this section. Mr. Sootmelk's wife bakes homemade all-bran rusk for her family. The recipe that she uses is shown below. So this is a question that is very popular in mathematical literacy, a question whereby they give you a recipe. So the ingredients, this recipe, it makes 30 rusk. Very important to know that your recipe is able to cater for how many, or how is able to produce how many items. And the baking time here is 55 minutes. So these are the ingredients. You need your 500-gram butter, up to 100 grams of pecan nuts, and the oven should be heated to 180 degrees Celsius. We are happy with this information. So the question, they say study the recipe alongside. We have done that, and answer the questions that follow. Question 1.1, how many grams of all-bran wheat flakes are needed for this recipe? I want you to take a look at this recipe and look for the all-bran wheat flakes. Where are they? There is the all-bran wheat flakes. What was the question? How many grams? How many grams is it? It is 240 grams. So the answer there, it is 240 grams. That's it. And then you get 2 marks for this answer. 1.2, each batch of rusk needs to be baked for 5 minutes. The last batch was taken out at the time indicated on the watch. Convert, I'm sorry, it's not for 5 minutes. It was actually supposed to be 55 minutes. So this is a typing error. Each batch of rusk needs to be baked for 55 minutes. So convert the 55 minutes to hours. Remember, I spoke about the conversion between time. You must know them. The conversion factor between minutes and hours, the conversion factor there is what is? It's 60. It's 60. So you are converting from a smaller one to a bigger one, meaning that you are going to divide. Always, when you convert from a smaller one, remember, from a smaller one to a bigger one, we are always going to divide. So we'll take the 55 minutes and then we'll divide that by the conversion factor, which is 60. I cannot guess the answer. I'm going to take out my calculator. I'm expecting you to do the same. You'll say 55, divide that by 60. The answer that I'm getting there, it is 0.91666, a lot of 6. So let's round it off to 2 decimal places, 0.92 hours, because there was no instruction whether we should round it to the nearest whole number or not. But that is your number of hours if you are converting 55 minutes. 1.3, each batch of rusk needs to be baked for 55 minutes. We've established that. The last batch was taken out at the time indicated on the clock. So the last batch was taken out at 4:30. The question is, what time did they put the rusk in the oven? So there are different ways of doing this. You can do it manually or you can do it using your calculator. When you use a calculator, 4:30, okay, they didn't indicate the time in the evening. So I'm gonna use manually that if I'm at 4:30, if I go back to 25 past, that is 5 minutes. So I want to count up to what? Up to 55 minutes. So this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So if they took it out at 4:30, it means they put them in what time? At 25 to 4, which is what? Which is at 15, 30, 35. So this is the time where they put the rusk, and then at 15:35, and then that when you count 55 minutes, that is why they had to take them at 4:30. So it can either be at 15:35 or it can be at what? At 3:35, because they didn't indicate whether the time it was in the morning or it was in the afternoon. But this is the time where they put the rusk in the oven. 1.4. Write down the type of time format that is displayed on the watch. So the type of the time format that is displayed there, it is the analog. Remember what we have? We've got analog. What is the other one that we have? What is the other one that we have? I want you to think about it. What is it? The digital. The other one is the digital. So how would you spot the digital? The digital would normally be given like this. It's not in a clock format. Let's say maybe it was 9 o'clock. It would be like this. So this would be your digital, and this one that is using a clock would be your analog. The last batch was taken out at the time indicated on the watch below. Write down the time indicated on the watch in a 24-hour format. Remember, with the 24-hour format, that is, we are talking with 1300, 1500, 1700, 2300, 2000. That is your 12-hour. That is your 24-hour time format. So here we can see that this is actually 4:30. But because now we want it in the 24-hour format, with the 24-hour format, you just add 12 to your hours. So when I add 12 there, it is how much? It is 16:30. The way, if you want to convert from your 12-hour to your 24-hour, the key is just to add 12 hours on your number of hours. So the correct answer here, it is 16:30. Number 2, Mr. Masenya purchased a bigger geyser. It means initially he had a smaller geyser. The family purchased a 200-liter geyser. So this is the bigger geyser that he bought. That is twice the size of their old geyser. So if this is twice the size of the old geyser, it means what is the size of the old geyser? If there's the 200 is 2 times bigger than what they used to have. It 2 times bigger, it means the older geyser was actually how many liters? It was 100 liters, because 2 times 100, it gives you 200. So the old geyser was 100 liters. The new geyser is 200 liters. That is what we have. Right. A table showing the dimensions of standard horizontal round geysers is shown. So we've got the capacity of the geysers. Our focus here is on the 100-liter that they used to have, the old one. And the dimensions of that old heater, it has a diameter of 550 millimeters. It also has a length of 840 millimeters. The new one that they bought, the 200 one, the 200 liters, it also has a diameter of 550 millimeters, but the length now, it is 1470 millimeters. So when we talk about the diameter, that is the distance from here to there. And when we talk about the length, we are actually referring to the height. This is the length of that particular geyser there. 2.1. Write down the dimensions of the old geyser. Remember, what was the size of the old geyser? It was 100-liter. And what are the dimensions? It is 550 millimeters by 840 millimeters. So when you answer this, you will say it is 550 millimeters by what? By 840 millimeters. So these are the dimensions. Calculate the circumference of the base of the new geyser. The base is the bottom part. The bottom part, that bottom circular part of the geyser. And you may use the formula. Circumference of a circle is pi multiplied by diameter, where pi equals to 3.142. Remember what I said, that the formula will always be provided and the value of pi will always be provided. So we want the circumference of what, of the new geyser. What is the capacity of the new geyser? It is 200 liters. So let us perform our calculations. We'll say circumference equals to, what is the value of pi? It is 3.142 multiplied by, what is the diameter of the 200? It is 550. So we'll say 550 millimeters. I need all of us to do this one on our calculators. We say 3.142, and then we multiply that by how much? By 550 millimeters. And I am getting the answer of 1728.1. And the units are what? They are millimeters. So this is how you calculate the circumference. Remember, the circumference is the same as perimeter. That is why you see that the units are just left in millimeters. There are no square units. 2.3. Calculate the circumference of the base of the new geyser. We already calculated for the new geyser, so let's make this the old geyser. So let's say calculate the circumference of the base of the old geyser. Remember, what are the dimensions of the old geyser? It is 100 liters. So we'll use the same formula to say that circumference equals to, what is the value of pi? It is 3.142 multiplied by, what is the diameter? The diameter of the small geyser, it is 550 millimeters. 15 millimeters. You must notice that because their diameters are the same, that would mean that their circumference will also be the same. So the circumference of the bottom part will be the same, which is 1728.1 millimeters. That is the circumference of the old geyser. It is the same as the new one. 2.4. Mr. Masenya wanted to be sure that the stated capacity, this is the capacity of the geysers, is correct. So he performed the following calculations. This is for the old geyser, the 100 liters. Where is the 100 liters? Here. So you are looking at this column here. So the volume is pi multiplied by radius squared multiplied by length. That is the formula. We are happy with the formula. And then Mr. Masenya said pi multiplied by, it's a radius there, but then he substituted 550 millimeters. Remember, we've got the diameter. The diameter is 550 millimeters. Therefore, the radius would be how much? We will say 550 divided by 2, which will give us a radius of 275 millimeters. That is the radius that we are expecting, but we see there Mr. Masenya used 550. And then the length is 840. It is correct. And then he punched in everything on the calculator to get this answer. And then he converted from millimeters to cubic centimeters. From cubic millimeters to cubic centimeters. But there is no change here. The answer is still the same. The answer is still the same. This answer and this answer, they are the same. The only difference are what are the units. And then converted from cubic centimeter to get this number of liters. So the question is, identify 2 possible errors that were made in the calculation above. I want you guys to look at this and try and identify any two mistakes that you think Mr. Masenya performed while he was doing these calculations. The first mistake is that he did not use the radius. He substituted what? The diameter instead of the radius. That is mistake number one here. He substituted, let me write it down. Substituted diameter instead of radius. That is mistake number one. And then the second mistake that I noted is that he used the value of pi as it is from the calculator. He didn't use the pi that we use, which is 3.142. Value of pi from the calculator. And then they only wanted 2 mistakes, but we can note the third one, that the conversion between cubic millimeters and cubic centimeters was incorrect. So we are supposed to know 2, but I noticed 3. You can even check the conversion between centimeters and liters if it is correct. If it is not correct, it means that is also another error that this guy might have committed. But lucky for you, as Mathslit learners, I don't think this is any of the mistake that you guys will be committing in the near future. 2.5, calculate the capacity of the new 200-liter geyser and round off your answer to the nearest liter. You may use the formula volume equals to pi times radius squared times length, and then the value of pi, it is 3.142. Now, okay, let's see, where do we start here? The 200-liter geyser, these are the dimensions. And our formula wants a radius. So the first thing is to take that diameter. The diameter, it is equals to 550 millimeters. Therefore, our radius would be what? Would be 550 millimeters divided by 2. It is 275 millimeters. So they said they want the answer to the nearest liter. But since our radius is in millimeters and our length is in millimeters, but our conversion here is what is? It's centimeters. So what I'm going to do here, I'm going to convert everything to centimeters. Let me do it here. Radius is equals to 275 millimeters. What is the conversion factor between millimeters and centimeters? You guys must know this. You must know this. Between millimeters and centimeters, the conversion factor is 10. And you are moving from a smaller unit to a bigger unit. Therefore, you are going to divide by 10, which will give you 27.5 centimeters. So 27.5 centimeters. That is the radius. Let us do the length. Our length, it is 1,470 millimeters. Divided by 10, because we are also converting it, it is 147 what? Centimeters. Now everything is in centimeters. We are happy. Now let us substitute into the formula. To say now V equals to, what is the value of pi? We've got 3.142 multiplied by, what is our radius? This is our radius, 27.5 centimeters, and then we close the brackets. Multiply by, what is our length? Our length is 147 centimeters. So our V, which is for volume, is equals to 3.142, and then we times this by. Take out your calculators. We want 27.5 squared. That is 27.5 multiplied by 27.5. The answer that I'm getting then It is 756. I hope I'm on the right track. 756,25 multiplied by 147. And then we do the math. Now your web guys, you need to have a proper calculator. Let us punch in now on our calculator. 3.142 multiplied by the radians multiplied by 147. The answer that I'm getting there, I am getting 349,292,2125. And remember, this is what this is, cubic centimeters. But what was the answer? What was the story? The story was that every 1,000 cubic centimeter, every 1,000 cubic centimeters is equivalent to 1 liter. So if you want to know how many liters we can have here, let us divide by 1,000 centimeters cubed. It will tell us how many 1 liters are there, because every 1,000 represents 1 liter. So you take your answer then and then you divide it by 1,000. The answer that I'm getting there, I am getting 349,2922 liters. Was there an instruction that we must round? Oh yes. Round off your answer to the nearest liter. When they say the nearest, they want your answer to be as a whole number. It means they don't want any decimal, any fractions. It must either be a 1, a 2, it must just be whole. So let's round this to the nearest whole number. The answer would be 349 liters. So this would be the volume of what? This is the volume of the 200 liter capacity. So the Geyser is written that it is 200 liters, but in actual fact, its capacity, it is actually 349 liters. How nice, how wonderful is that? I hope you're able to follow. I know it's quite lengthy. It's very lengthy, but it is not difficult. And this is how these questions are asked in the exams. So you just try and see where you can collect the marks. You fix your radius, you fix your conversions, you make sure that your units are what the question is looking for. You substitute into the formula. The formula will always be given to you. Then you are on the right track. 2.6. Should Mr. Masinya be happy with the new Geyser based on the capacity? Remember, the size of the new Geyser, it is 200 liters, but it has a capacity of what? It means when you fill it with water, it can actually carry how many liters of water? It can carry 349 liters, which is good. It carries more water. So should he be happy with the new Geyser? I would definitely say yes. The reason is why it carries more water. It carries more water. But another person can say, no, he should not be happy, because if it carries more water, remember for a geyser to warm up, you need to warm it up using electricity. So it means if there's more water, it will take longer to warm up, meaning that it will use more electricity. So another person can say no, the reason being that it will use more electricity to warm up the water, which is another cost. More electricity to warm up the water. So it is up to you whether you think it's a good idea. Provide a reason. If you think it's not a good idea, also provide a reason, a valid reason. Number 3, a farmer in the United States of America uses the containers below to store and supply milk to local factories. So here we've got 330-gallon IBC tote, and the inside dimensions of this IBC tote is got a length a width and a height that are given in inches. And then there's also the 55-gallon drum. And then this 55-gallon drum is got a diameter of 22.5 inches. Let me write it down. This is the diameter. And then it also has a height. This is a height of 33 inches. Remember, this is in the United States. That is why you see that the units are in the imperial format. And when we are working with imperial units, you'll always be given the conversion factor as it is indicated here. So question 3.1, convert the 55 gallons to liters. So do we have the conversion factor? We do have it. We know that 1 gallon is equivalent to 4.546092 liters. I've been talking a lot. I want to give you guys a chance to do this one, just 2 minutes. And then when I come back, we'll do it together so that we can check yourself whether you are on the right track or if you still need assistance with this section. 2 minutes. Welcome back. Let's do this together. I hope you guys have the answers now. So remember, what are we doing? We are supposed to convert the 55 gallons to liters. We don't know the conversion factor. We are not even expected to know it. That is why they give us the conversion factor. What is the conversion factor? They say 1 gallon is equivalent to 4,546 092 liters. You don't round off. You work with it as it is. You don't round it off. And then since we put the gallons this side, the 55 gallons that we want, we are also going to put it on the left hand side. So we will write 55 gallons here. And then what are we looking for? We are looking for the number of liters. You can either make it a question mark or write liters, whatever, it's up to you. So 1 multiplied by the number of liters, anything multiplied by 1, it is the same thing. So it is liters. And then here we are cross multiplying, guys. We'll say 55 multiplied by 4,546,092. And then you take out your calculator. You say, remember the gallons, they cancel. This is gallon, so they are the same. Therefore, they cancel each other. So here we are just left with what? With liters this side. So you will say 55 multiplied by 4.54 6092. You punch it as it is, 4.546092. You punch it as it is, and the answer is 215,03506 liters. But what was the instruction? To the nearest whole number. Nearest whole number, remember I said it means your answer is not supposed to have any decimals. So the answer here is actually 215 liters. So this is how you convert 55 gallons to liters. This should tell you that it means a gallon is a bigger unit as compared to your liters. That is why you see we were multiplying, because we are moving from a bigger unit to a smaller unit. I hope you guys got the answer correct. Remember, I asked you to do this one on your own, and then we can compare the solutions. I hope you all got it right. 3.2, you must show through calculations if the IBC tote, where is the IBC tote? It is this one. It can hold more than 310 gallons of milk. And you may use the formula length times width times height. So what do we have here? We've got our length in inches, our width in inches, our height in inches. And then we also know that we've got a conversion factor between inches and centimeters. And then we know that a gallon can also be converted to liters. I don't know. You guys might have an easier way of doing this, but I'm trying to do this the best way I can understand it. Because right now I am so confused about the 310 gallons. I'm wondering, what is 310 gallons? So because I'm not familiar with the gallons, I'm going to convert these gallons to liters. So I know that liters are smaller. So if I'm converting from gallons, from the bigger one, which is gallons, to a smaller one, which is liters, I am going to multiply. The conversion factor, it is 1 gallon. It is equals to 4,546092 liters. And what do I have? I have 310 gallons. So remember, I said that I'm moving from a bigger one to a smaller one. Therefore, I'm going to multiply by what? By the conversion factor, which is 4,546092, which is equals to, so we'll say 310 multiplied by 4.546092. It is 1,409,28852 liters. So it means when I calculate the volume, I'm looking for more than 1,409,28 liters. I forget about the gallons because I don't understand them. So I want to see if the volume will be more than this. So but before I can calculate my volume, I need to convert this. I need to convert the length, the width, and the height. The conversion factor there, it's 1 inch is equals to 2.5 centimeters. Again, an inch is bigger than a centimeter, meaning if I'm converting from inches to centimeters, I have to multiply. We multiply by how much? By 2.54. So it means the length here, we must multiply it by 2.54. The width, we must multiply it by 2.54. The height, we must multiply it by 2.554. I want to write down the volume there, that they say it can hold more than. The volume, we said, is 1,409,28852 liters, so that I can use it in the next slide, because now we no longer have enough space here. So remember I said, I'm sorry, apologies for this. We we said that it must be more than 310 gallons. Let me see. Okay. I was looking for enough space. I don't think we'll have enough space here, but it's fine. Let's try and work with what we have here. So the length, 48 multiplied by 2,54. The answer is 121. So the length is 121,92. Please bear with me because of the space. And then we take the 40 inches, we multiply it by 2,54. Please work this out with me. Use your calculators there as well. It is 101,6. Remember now, these are in centimeters. We are converting this now to centimeters. And then the 46 multiplied by 2,54. The answer that I'm getting there, it is 116,84 centimeters. And then we're taking it back now. We are substituting now into the formula to say volume equals to, what is the length? The length is 121,92 centimeters. What is the width? It is 101,6 centimeters. What is the height? The height is 116,84 centimeters. So what are you going to do now? You are going to take your calculator. You are going to punch in this volume. Find the volume in cubic centimeters. After finding your volume in cubic centimeters, you are going to use this conversion factor to convert your volume into milliliters. And then after doing that, you will be able to answer this question. I'm going to give you guys exactly 1 minute because I want to create enough space for me to work out the solution. So you do it on your side there, and then after 1 minute, I'll be back. Then we can finish it off together.
I want you to ask yourself these 3 questions. Number 1, what do I want? Do I want to become an A student, or do I want to become an average student? Number 2, I want you to ask yourself, how do you plan on getting there? Are you going to put more extra hours, or are you going to just sleep? Number 3, who will be with you in this journey? Because it is important that we associate ourselves with students who have the same vision as us, who want to become a student, who want to put in the extra work, who want to become better at what they do. Unsuccessful people do not plan. They just let life happen to them. But successful people are planning on how they want their lives to be. And right now, you plan on how you want your results at the end of the year to be like.
Welcome back, guys. I hope you are close to the answer, or well, you have the answer. I wish you could give me the answer. I wish I could talk to you so that you can give me the answer. But nevertheless, it's okay. So let us now multiply our values. It's 116,84 multiplied by 101,6 multiplied by 121,92. And the answer that I'm getting there, I am getting 1,447,305,492 centimeters cubed. But remember, we want what we want, liters. We want to see how many liters this really is. So we've got a conversion factor here. Between cubic centimeters and millimeters, it is 1 milliliter. They say 1 milliliter is equals to 1 centimeter cubed. So it's nice. The ratio is 1:1. So it means this is actually 1,447,305,492 milliliters. Now we need to convert from milliliters to liters. How do we convert from milliliters to liters? We know that 1 liter is equals to how many milliliters? 1000 milliliters. Between a milliliter and a milliliter is smaller. So we are converting from a smaller one to a bigger one. What do? We are going to divide. Therefore, we are going to divide here. We divide by what? You divide by 1000. Divide this by 1000. I've run out of space. Let me write it here. Let me write it here. So when we divide this by 1000, the answer that I'm getting there, it is 1447, 305 liters. I'm sorry, I have to round it off. What was the instruction? That it can hold more than 1409. Look at 1447, 1409. 1447 is bigger than 1409. Therefore, we say the claim was valid. So this is a valid claim. Or we don't even have to do that because we had to show. And that is exactly what we do. We show that it is more than the 1409 liters. This one is a higher order question. It's a bit of complicated, but unfortunately, these are the questions that we cannot avoid because they are there in the exam and we are expected to answer them. So you do it in smaller chunks. You start with your conversions. See what is it that you can convert depending on what is given to you. I promise you, such a question, it will normally be around 7, 8, or 9 marks. It's very rare that learners get 0 for these questions. You might even get 6 out of 9 from this question, especially from your conversions. You convert there and there, you substitute into your formula, but you make sure when you substitute the units that are the same. You cannot substitute carrots with apples. The units must be the same. 3.3. The farmer decided to paint the total external surface area of the drum, this is the drum, to keep it away from rusting. The spread rate of the paint is 2.5 square meters per liter. So, and the paint is sold in 1 liter tins. So when you go and buy the paint, it is only sold in 1 liter tins. So this means that if maybe our answer when you're calculating, we calculated 2.3 liters. You can't go to the shop and say, hey guys, I want 2.3 liters. No, it is sold in 1 liter. It means you buy 2 liters, but you must buy another 1 liter. Meaning how many liters are you going to buy? 3 liters, because it is only sold in 1 liters. Calculate how many tins of paint will be needed to paint 1 drum. You may use the formula, the surface area of a cylinder in square meters. It is 2 times 3.142 multiplied by radius squared plus 2 into 3.142 multiplied by the radius multiplied by the height. Again, here we are going to have a challenge of space. They want us to calculate how many tins of paint will be needed. And then the spread rate that they gave us, it is square meters. It means that when you calculate the area, or they want us to calculate the area in square meters, but the dimensions of our drum, they are in what? They are in inches. And then the conversion factor that we have is between inches and centimeters. So let us do our conversion here. The diameter, it is equals to 22.5 inches. We are moving from a smaller one, a bigger one to a smaller one. We are now going to divide. We are moving from a bigger unit, from a bigger unit to a smaller one. We are still going to multiply. So 22.5 inches, we multiply by how much? By 2.54. This is equals to, remember this is the diameter. So we say 22.5 multiplied by 2.54, and the answer would be 57.15. And this is what? This is centimeters. But we want what we want? We want meters. So from centimeters, it's a smaller one. You're moving from a smaller one to meters. A centimeter is smaller than a meter. So from a smaller one to a bigger one, you are gonna divide. What is the conversion factor between centimeters and meters? It is 100. So you are gonna divide this by 100, and then to get the answer of what? Divided by 100, it is 0.5715 meters. This is the diameter, and we are not done. Since this is the diameter, you want the radius, because for you to substitute in the formula, you need the radius. To get the radius, you'll have to divide that by 2. Further divide by 2 to get the radius. The radius is 0.28575 meters. That is the radius we are having. Now we want the height. The height is 33 inches. We are going to multiply by the conversion factor of 2,54 to give us. So let me press it. 33 inches multiplied by 2.54. The answer is 83.82. But remember, this is what? This is centimeters. So to convert it to meters, you will divide by 100 to get what? To get 0.8382 meters. So this is the height. I apologize for the space. I really do not have enough space now. So now let us come and substitute this into the formula. This is equals to 2 times 3.142 times, what is our radius? This is the radius. The radius is 0.28575. It must be what? It must be squared. Close the bracket. Plus 2 times 3.142 times the radius is what? 0.28575 multiplied by the height. What is our height? Remember, this is our height there in that corner there. 0.8382. Close the brackets. Whew, I'm glad everything was able to fit. So I'm gonna do it the entire bracket. Remember the radius here, we square the radius. Because I don't have space, I'm gonna do everything as it is. I'm gonna say 2 multiplied by 3,142. I hope you are following with me. Multiply that by 0.28575. It must be squared. So the 0.2575, it must be squared. And then the answer is 0.5131078. I'm writing all the values because I'll only round off at the final answer. So you include all your values. And then the second bracket, it is 2 times 3.142 multiply by the radius of 0.28575 multiply by 0.8382, and the answer is 1,505. I don't have the space, I'm sorry, that's why I'm not including all the decimals here. Plus I'm adding those two now. 0.5131078. We are getting 2,018,224. Remember, what are we working with here? Our answers, we're working with meters. So this is meter squared. But then our spread rate of paint, for every 2,5 square meters, you need what? You need 1 liter of paint. So for us to determine how many liters of paint we need to buy, we can divide this by the 2,2, 5 meter squared. We can divide it by the spread rate. Or you can just say that, okay, 2,5 meters squared, you need 1 liter for that. Meaning that for 2, okay, let me close this here so that they don't mix up. For 2,018,224 meters squared, how many liters of paint do you need? You make it a question mark. So here on, you cross multiply. After cross multiplying, you will get the number of paint that you need to buy. And remember, if you get a decimal number of liters of paint here, you need to round it up. You don't round down because your paint is only sold in 1 liters. If your answer is going to be 1,2, it means you need to buy 2 liters of paint. If your answer is 5,004, it means you need to buy, you need to increase it by 1. So because it is paint, but we do that with all the building material, we always round up because it's better that you buy extra. It's better that you have something that is left over rather than you have a shortage. Girls and boys, unfortunately, because of time and because of my space here, we have come to the end of our session. Today's session was very intense. I hope you guys survived. I hope you understood. And I hope you'll be able to tackle this when you come across this in the exams. And I'll make sure that I include this in our paper 2 final push preparation so that we can continue from where we left off with this problem. Thank you so much for tuning in and joining us this afternoon. We will see you again next time as we prepare for the paper 1 and the paper 2 final push.